My baloney has a first name, it's O-S-C-A-R. My baloney has a second name, it's M-A-Y-E-R. Oh, I love to eat it every day, and if you'll ask, that's what I'll say. 'Cause Oscar Mayer has a way with B-O-L-O-G-N-A.
Well, hey there, everybody. Welcome to Chapter 5 in our Big Ideas Geometry Curriculum. And so what you see before us is a list of what we'll be doing through Chapter 5, looking at congruent triangle. That's the overall title. And then we'll specifically get into each section one by one. So our first section here in 5.1, as you can see, is angles of triangles. And so let's take a look at 5.1. So I did that little Oscar Mayer song. Maybe some of you have heard that before, but that was an old 1975, I think, commercial came out with that little jingle about the name for bologna. And so I chose to do that one just because for triangles, we got to give them a name. It said my bologna has a first name and my bologna has a second name. And so that's the same thing we got to do with triangles as well. We're going to see that we're going to be classifying triangles by sides and by angles. And so that's what we'll see. We'll give it a triangle is going to have two names. It's going to have a first name. It's going to have a second name for the triangle. We'll also look at finding interior and exterior angle measures of triangles as well. But here's our cartoon of the day before we get started. So you had some socks headed to the dryer. Field trip today for the socks. And then one sock says, "Okay, everyone remember the buddy system." It seems like every time I send my socks to the dryer, I get one of them gets lost, and you get one sock back, and it's like, hey, what happened to the other sock? All right, here we go. 5.1, starting with our core concept on page 125. We are classifying the triangles both by sides and by angles. So again, you have your, every triangle. My triangle has a first name, and it is by usually sides or angles, and that's my triangle has a second name as well. So typically when we're going to name a triangle, we typically name our triangle by angles first, and then we name it by sides. So the first name that we typically give a triangle is by the angles here, and there's four possible first names of a triangle. It's acute, or right, an obtuse, or an equal angular. And so we've already talked about acute, right, and obtuse angles, but we can also have those for triangles. That means you have acute has got three acute angles in there. A right triangle is obviously going to have one right angle in there, and then an obtuse has one obtuse angle in a triangle. But if all the angles are exactly the same, then we call it an equal angular triangle. And so that's going to be our first name. So our first name is going to be either acute, right, obtuse, or equal angular. Our second name is going to come from classifying it by the sides, and that's going to be either scalene, isosceles, or equilateral. Scalene is all about the sides now not being congruent. None of the sides are congruent. So if there's not any sides that are the same, we call it scalene. If two of the sides are congruent, at least two sides are congruent, we call it isosceles. So you can see the little congruent marks there. If all three sides are congruent, they're all equal, then we would call it equilateral. So that's going to be our second name. So our first name could be one of these, and then second name is going to be this. So you could have like a acute scalene triangle, or an acute isosceles triangle, or a right scalene triangle, or right isosceles, and so on. All right, so here's a triangle made out of these beams on this picture. It just says, okay, how would we classify this? What's the first name? What's the last name? And so obviously, you would look at the angle measures inside of here, and these are all acute. They're all less than 90, so we know it's going to be an acute. That's the first name, and also you can see the little congruent marks right here. So these two are the same, so it's isosceles. So that would be an acute isosceles triangle. That was how we would name it. So it is an acute isosceles triangle. All right, so on page 127, your extra practice, I'd like you to try these on your own here, 1 through 3. Just go ahead and give it a first name and a second name. The third name could be triangle, so you could say, it's a triangle. So you want to do that. Go ahead and give it a first name and a second name, and even put a little mark here on number 2 to help you. So go ahead and pause the video and name each one of these, classify it by the angles and the sides. All right, so hopefully at this point you're playing it again to check to see, did you classify this correctly? Did you give it the first name and then second name correctly? So this one here, number 1, this should be an obtuse scalene, because you do have one obtuse angle right here at Q. That's definitely more than 90. And none of the sides are the same. They're all about different measures. Number 2, on this one, we should be calling it a right scalene. Definitely this is a right angle. When I showed you, that's a right angle, so definitely a right triangle, and it's also scalene as well. None of the sides are exactly the same. No congruent marks anyways. And then this one for number 3 should be acute isosceles. They are all acute angles inside here, and then these two are showing the congruent marks, so it's isosceles, acute isosceles. All right, so our next problem is going to look something like this. It's going to give us a picture of it, and we need to classify it, by its sides, and then determine whether it is a right triangle. And so to classify it, that's those 3 names. Is it scalene? Is it isosceles, or is it equilateral? And definitely we could see it's not equilateral. This one's definitely shorter, but these two could be the same measure, so it could be isosceles. That's really kind of, you're thinking maybe isosceles or maybe scalene if they're not exactly the same. So how do we figure that out? So all you need to do is make sure you just use the distance formula with your points here to see what's the distance between P to Q and what's the distance between O to Q. And that's what they're going to do. They're actually going to do it for all 3 though. They find the distance for all 3 sides. Of course, this short side is definitely a lot shorter, or actually, no, there it is, 2.2. It's just a lot shorter, that first one. But then as they did the distance formula with the other 2, they saw, okay, 6.7, 7.1, they're not exactly the same distance. So they're not congruent. So that's not isosceles, that would be scalene. So it is a scalene triangle. So now we have to figure out, okay, is it a right triangle? Well, definitely, that's not a right angle over here at Q. This one here, maybe, but that still looks a little bit less than 90. This is the one that could be. I would say O was the one that's probably closest to a 90 degrees if it is. And so we could check that by finding the slope of O to Q and the slope of P to O, or O to P. So find the slope of these 2 right here and see if they are opposite and reciprocal, or if you multiply those 2 slopes, if it equals -1, that would tell you they're perpendicular. So that's what we need to figure out. Are these 2 lines, these 2 sides, perpendicular here? And so that's what they're going to do next. They're going to find the slopes, and they do find that you get a slope of 1/2, and you also get a slope of -2. If you multiply those, you get -1. So that definitely is a perpendicular slope, or it's opposite and reciprocal, showing definitely it's perpendicular. So yes, it is a right triangle. So it's scalene, and it's a right triangle. All right, so let's call our extra practice now. All right, so for number 4 on the extra practice, that's what we need to do. So you do not actually have the picture of it. We have to actually draw the picture. We only have the points. So on your paper, you need to draw a coordinate plane. And let's draw this picture. So we got to plot our points. So we have A at 6, 6. So go right 6 and up 6, and we'll have A there. And B is at 9, 3. So right 9 and then up 3. B is over here. And at 2, 2. So right 2 and up 2. So everything is in the first quadrant here. So you can really just make the first quadrant really big, on your coordinate plane. I didn't need all these other quadrants in this one. I just needed my first quadrant. And so now I'm just going to connect my dots together to make my triangle. So I can definitely see here, we got to try to classify it by the sides. So is it, it's definitely not all the same, as you can tell. It's not equilateral. But it could be, maybe it's obviously could be scalene. They could be all different. Or it could be maybe isosceles with these 2. This is definitely a shorter one from A to B, but these 2 could possibly be the same. So we'd want to check the longer 2 and just see, are they really the same with the distance formula. So from A to C, we'll do our distance formula for that. And so again, that's where you just take the x's, subtract your x's of those 2 points and square it, add it to subtracting the y's of those 2 points and also squaring them. And so that's going to give you 6 minus 2 for both of them, because it's a 6, 6 here, it's a 2, 2 here. So that's going to give you 16, so this is 4 squared and 4 squared, so 16 plus 16 gives us the square root of 32. That's the distance from A to C. Now if we try from C to B, or B to C, if we do that one, our distance formula for this one, now here the x's are 9 minus 2, and the y's are 3 minus 2. So this is going to give us a 7 squared, this will give us a 1 squared, and so we're going to get 49 from 7 squared. and then just 1 from one square. That's 50, so the square root of 50, which shows us right there those are not the same. They're not exactly the same distance, so that means that they're all different lengths, and that's definitely going to be a scalene triangle then. So classifying by sides that it's scalene. And then it wants us to determine whether this is a right triangle. So now we need to figure out, okay, obviously this corner here is definitely acute. This one looks pretty acute over here at B, but it's A that I would probably check to see, is this a right triangle here, or right angle here on A? So I want to use the slope, or find the slope of AC and find the slope of AB. Those are the two slopes I want to look for. So the slope of AB, we can just do rise over run. If we can count that, that's fine. Or we can, subtract the points or whatever we want to do there. We can subtract the y's on top and the x's on the bottom. But if I just rise over run, that means you're going to go up 3, positive 3, and then left 3, negative 3. So one's negative, so it's definitely a negative over positive. So your rise could be, or you could go A to B, you could go down this way. I think that's probably what I did to get negative 3 from A to B. I went down, negative 3, and then right 3. So it's a negative 3 over 3, which is negative 1. So that's the slope of AB. The slope of our AC now, that will be rise over run here. So if I go from A to C, I'm going to go down, looks like 4, and then left 4. Or I could go up here. I could go up 4 and right 4. So either way, I'm going to get 4 over 4, or negative 4 over negative 4, still positive. It's going to be a positive slope. 4 over 4 is also 1. And so since these are opposite reciprocals, they're not necessarily opposite, but, or they are opposite, they're not necessarily reciprocal because there is no reciprocal of 1. But if you multiply these two together, you would equal negative 1. So that definitely tells you these are perpendicular. So they are opposite and reciprocal because, it's reciprocal of 1 is still 1. So they are perpendicular lines, which tells us that it's a right triangle. And so that's what it would be. It would be a scalene and a right, so it would be a right scalene triangle if we were to classify it by both. All right, so here's our joke of the day. What did the cross-eyed teacher say? I can't control my pupils. Hopefully you know that pupils is another name for eyes. Okay, so on page 125, back to 125 of your notes, there is some vocabulary now to do here. We have 2 of them, interior angles, exterior angles, and it may be good if you drew the picture. I would draw the picture there on your paper. So you could just draw 3 intersecting lines like this to get a triangle like this here, and then maybe shade the angles on the inside. Those are interior angles. If you just do that, then you don't really need to write it down, because over here it does say that the interior angles, the original angles are interior angles, or they form on the inside. Those are your interior angles, so you definitely want to do this. There's not a lot to write down. When the sides of a polygon are extended, so if we extend these sides, so here's a triangle and these sides are extended out. Other angles are formed. The original angles, which are the interior ones, those are the original ones on the inside. But then as you extend them out, you can get some other angles here, which are your exterior angles. Exterior angles are on the outside, as you can see right there. So if we were to do this one here, and just draw one line going straight this way from A through B, and then B through C, and then C through A, then these here would be our exterior angles on the outside. Interiors will be on the inside, and your exterior ones are going to be on the outside. So I'd draw both of these on your notes. If you need to pause the video so you can continue to draw them and then play it to finish up the next section. Alright, so as we go on, page 126, if you turn the page, we have a theorem here, which is something you should know already. We've already discussed this. This triangle sum theorem is just that all the angles in a triangle always add up to be 180. That's something that you should have learned before, and also we've talked about it already in our class and even used it as well. So you just know that all the interior angles here, all these interiors, so they were using that interior angle word again there, all the interior angles will add up to 180 in a triangle. So the measure of A plus the measure of B plus the measure of C equals 180 inside here. Another theorem for the exterior angle theorem. So here's exterior angles. So if I continued to draw A through C and I got an exterior angle here at 1, what we could find out from that, it says the measure of an exterior angle, like this one right here at 1, of a triangle is equal to the sum of the measures of the two non-adjacent interior angles. So you have your 3 interior angles right here. I highlighted these, so you may highlight these ones right here. So we're talking about angle B inside here, angle A there. Those two, if you add them together, that's going to equal this exterior angle. So obviously not this one here, that's adjacent to it. These are non-adjacent interior angles over here. So the measure of this angle 1 equals A plus B, the measure of A plus the measure of angle B. So here's a quick example of that. So as you can see, here's our exterior angle. It says 2x minus 5, and then the two non-adjacents are given to us here for x and 70. It does say to find the measure of the angle JKM. So JKM is this exterior one. So you're going to try to find that angle measure. We would need to set up an equation to solve for x first, and then plug the x in here, and that would give us our degrees for the exterior angle. So these two add up to equal this, or this right here, 2x minus 5 equals the x plus the 70. So that's the first thing you want to do. That's there, you're writing, you just set up your equation, then you just solve your equation. And so that means x would be 75 once you do solve it. So if you were to subtract the x, bring that over here, add the 5, it's 75. And now we plug in 75 for right here, so 2 times 75 minus a 5 would give us our answer. That's what we would do for that. Substitute it in, and it gives us 145 degrees for this exterior angle. Okay, so back to our extra practice on page 127. It says find the measure of the exterior angle. So I want you to try that for number 5. Just figure out, okay, what is the measure of angle 1? Go ahead and do that using that exterior angle theorem. Go ahead and pause the video and then do that, and then play it to see if you got 5 right. Alright, so hopefully you have an answer for 5. So again, the exterior angle 1 is going to be the sum of the two non-adjacent interior angles. That's these two guys right here, 53 and 53. We just got to add those together, and that's going to equal what 1 is. So you just add those together. 53 plus 53 is 106 degrees. That's what you should have then for number 5. Number 6, this one, the same idea, but we have to figure out what the x is, just like we saw in that previous example. So this right here, 8x minus 5, is going to equal these two added together. So you got to set up your equation. We'll start with the exterior angle part. So 8x minus 5 is equal to the sum of these two non-adjacent interior ones. So we could say 5x plus 15 plus 40. That's a positive 40. And so now we need to solve this equation. So go ahead and solve the equation, and then once you've solved the equation, you know what x is. Plug x in here, and then figure out how many degrees that is. So I'll give you a chance to do that. Go ahead and pause the video and finish off number 6 now, and then play it just to see that you got that correct. Alright, so hopefully you have an answer now. You know how many degrees this is. Let's just check your answer. So as I simplify over here, I simplify this side, 15 and 40 make 55. And then I'm going to bring my 5x over to the other side. I'm going to subtract 5x from both sides. That cancels them here. And 8 minus 5 gives me 3x on this side minus a 5 equal to the 55. And I'll then bring the 5 over. I'll add 5 next to both sides. And so that gives me now 3x equals 60, because those will cancel. And I'll divide by the 3. So 60 divided by 3 gives me 20 for x. So that's what the x equals. But now you got to plug 20 in here for x. 8 times 20 minus 5, so I'll do that up here. 8 times 20 would be 160, and 160 minus 5 is 155. So that should be your answer for the exterior angle, 155 degrees. Alright, so on page 126 there was one last kind of theorem here. It's the corollary. Corollary just means it's kind of like the similar to one we've already talked about. It's a corollary to the triangle sum theorem, the one that says that all the angle measures inside here add up to equal 180. But if we see that it's a right triangle, and so we know that C right here is 90 degrees, then the corollary could be just that these two angles here are going to just add up to 90 then. So the acute angles of a right triangle are complementary. They will add up to 90 degrees. So that's what the corollary can do. So it's pretty much similar to that theorem with the triangle sum, but with a right triangle. All right, so this is at the bottom of 127, number 7 there. It's our last one. And this is one where we actually have to kind of figure out from the words here what they're trying to have us do. And they want us to figure out the measure of each acute angle in a right triangle. It says in a right triangle, the measure of one acute angle is twice the sum of the measure of the other acute angle and 30. So it says find the measure of each acute angle. So we have a right triangle. So first of all, that's what we know. We know we have a right triangle. Go ahead and draw a right triangle on your paper. So I'm just going to draw a triangle like this, and this should be a right angle. Just trying to make that look like a right angle right down there. Put a right angle mark. We know that this is 90 degrees. So according to that theorem we just looked at, the corollary, that these two are going to add up to 90 degrees. They're complementary. So as we start to, figure out, okay, how do we represent these two acute angles? So it does give us some information about each acute angle here. It says one acute angle is, all right, so one of the angles is this, twice the sum, so 2 times is twice the sum of the measure of the other acute angle and 30. So if we know what, we have one of the acute angles, if we add 30 to it and then times it by 2, that's going to give us the other one. So we need to say, okay, well, in this case, the other acute angle here is going to have to be just x. That's going to have to be just x, because once we just know whatever that is, that and 30, so that plus 30 times 2, or twice of the sum of that, so it says twice the sum of this. Sum means you're going to add the x and 30. That's going to give you the other one. So if we say, okay, now if this is our x, let's just say the top one here is x, doesn't matter which one we use, but if let's say this one is x, then this other acute angle here is going to end up being twice the sum, so 2 times the quantity with a parenthesis, because we're going to put a sum in the quantity. The sum is the sum of x and 30, the other acute angle, and 30, so x and 30. That's what we got. We can do a little quick distributive property there, and if we want to write it like this, we can say 2x plus 60 with the distributive property. This expression here represents this other acute angle. And so now according to that corollary, we can just add these two angles now together, and it equals 90. So we can make an equation that starts off with x plus the other acute angle here being 2x plus 60 equal to 90. Those two add up to 90, because we already got 90 over here. 90 plus the 90 makes the 180 for all of the angles in the triangle. So just solve this now, make this 3x when you combine like terms, and we're going to subtract 60 from both sides. That cancels it here. Now we get 30 on this side, so 3x equals 30, divide by 3, so x is 10. So that tells us one of the acute angles here is 10 degrees. So 10 degrees is one of the acute angles. The other acute angle, we're going to need to put 10 in here, times it by 2, add 60. So 2 times 10 is 20, and 20 plus 60 is 80. So the other acute angle would be 80 degrees. So there's our two acute angles, 10 degrees and 80 degrees. All right, so that concludes our lesson here for 5.1. You should be ready for the assignment, and I'll see you on 5.2.